Good morning, folks. Today we're going to be talking about partial fraction decomposition. Now, before we get into partial fraction decomposition, I first want to talk about another topic which could be reviewed for some of you, but is always worth going back over at this point. And so we're just going to talk about rational expressions. Now, we've already discussed rational functions, but really this is just, you can think of rational expressions of fractions with polynomials. And so this is when we did vertical asymptotes and all of that kind of stuff. We did vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept. We talked a lot about rational functions, but now we'll just talk about expressions. And specifically, I want to focus on operations. So this is add, subtract, multiply, and divide. Now, hopefully most of you remember just kind of, fractions. If I have something like 2/3 plus 5/7, you need a common denominator. So we would get 2 times 7 would give me 14, 3 times 7 would be 21, and then we have 15 over 21. So I'd get 19 over 21. Or you might also remember if I were to divide fractions, this is 2/3 times the reciprocal of the denominator. And then to multiply, you just go straight across, so I'd end up with 14 over 15. Additionally, you can use the Desmos scientific calculator to check your answers with numbers. Okay, so that was just a review of fractions. Now let's talk about rational expressions. We're going to be doing a couple different examples. So we'll just perform whatever operation is given. All right, so the first one we're going to do is 3 over 5x plus 7 over 3x squared. Now the first step to do is to figure out what a common denominator would be. So we can start with the numbers, the 5 and the 3. So the common denominator is definitely going to have 3 times 5. And a lot of times what we want to do next is take the x times the x squared. And so we'd end up with x cubed. And so then the common denominator would be 15x cubed, which you could do, but this could create work later on in terms of simplifying. So let's try to come up with a more strategic denominator here instead of x cubed. So I see that there's an x squared and an x. If I take my first x and multiply it by an x, I'll end up with an x squared, which is the same as the 3x squared. So that tells me that I don't actually have to get x cubed. All I need is 15x squared. Now, if you would prefer, again, just to do x cubed, that's fine. It would just create some extra work for you later on. So up here we did the same, right? We took 3 times 7 and we got a common denominator of 21. It's the exact same when you have x's in place. Okay, so now we have to get everything to be 15x squared in the denominator. So what I'm going to do is go 3 over 5x. I need to multiply by a 3 and an x to the top and the bottom. For this fraction, I need to multiply by a 5 to get the common denominator. So I end up with 9x plus 35 over 15 squared. And that would be my final answer. 9x plus 35, you can't do anything with that. You can't cancel out these x's. That's illegal. That's called home wrecking, because there's an implied set of parentheses up here above that horizontal line, which is called a vinculum. There's an implied set of parentheses there that can't just be broken up to get at the x that you want. So this would be our final answer. All right, let's try at least one more. Let's see where this takes us. So now I'm going to do something a little bit, hopefully more straightforward. When we have those x's and x squares, it tends to sort of throw folks off. So in this case, we have 2 over x and then x plus 1. A lot of times what folks will want to do is they'll say, well, I have an x plus 1, so let me just add 1 to this x and add 1 to this 2. But this actually fundamentally changes the fraction. So if you had 2/3 and added 1 to both, you would end up with 3/4, which is not equal to 2/3. So just to keep that in mind, you can't add to the top and the bottom and have the same, you can only multiply. So if I had 2/3 and I multiply the top and the bottom by 2, then I do end up with an equivalent fraction. So just keep that in mind throughout all of this. You can't just add 1 to the x and call it good. So let me go ahead and erase that before we write that down. Okay. So in this scenario, I will just multiply x times x plus 1. There's really nothing else I can do. And so this will be my common denominator. So what I need to do is have 2 times x plus 1. And then 1 will be multiplied by x. And now I do have the same denominator, so I'll go ahead and distribute and combine some like terms here. So I'll have 2x plus 2 plus 1x all over x times x plus 1. And then combining like terms, we end up with 3x plus 2 over x times x plus 1. Now the numerator can't be factored, so there's no canceling that occurs because I see no common factors. Right. So for the next one, so in these two examples we just did adding, or we could have done subtracting as well, it'd be the same process. For the next one I want to do a little bit more multiplying and dividing as well. So we're going to look at something called a complex fraction, which is when you have a fraction inside of a fraction, and here's what I mean. So I have x plus 3 over 4. I have to add 2 over x. That's my numerator. Notice how there are fractions within a fraction. And then I have 1 over x plus 3 over x plus 2. Okay, so just remember what I said here. There's technically a set of parentheses in the numerator and the denominator. So you have to do the addition before you can do this division. So let's go ahead and do that. So I'm going to rewrite the numerator as, let's see, the common denominator will be 4x. Oops. So for the numerator, the common denominator equals 4x. So let's go ahead and do that. X plus 3, I need to multiply that by x over 4x, plus 2 also has to be multiplied by 4. And so I end up with distributing x squared plus 3x. 2 times 4 is 8. And then in the denominator I get 4x. X squared plus 3x plus 8 cannot be factored, so I know that there's going to be no cancellations occurring. Let's go on to the denominator. In the denominator, the terms I'm adding up have a common denominator of x times x plus 2. So that means I need, let's see, 1 times x plus 2 over x times x plus 2. And then this fraction needs to be multiplied by x. And so I end up with, I guess we could technically distribute the 1, but nothing changes. So I get x plus 2 plus 3x all over x times x plus 2. Let's go ahead and combine those like terms. So I do end up with 4x plus 2 in the numerator. And just as a quick check, I could factor the numerator, so I would end up with 2 and then 2x plus 1. But notice you can't cancel any of these, so we don't actually need to worry about factoring the numerator. So we'll stick with this as our term. Okay, so let's put all back together now. We have our numerator and our denominator. The numerator was x squared plus 3x plus 8 over 4x. And then the denominator is 4x plus 2 over x times x plus 2. We need to take the numerator of our fraction. When we're dividing fractions, we take the numerator and multiply by the reciprocal of the denominator. I like to put parentheses around these just to remind myself what the factors are. And notice before we multiply, there is an x factor here and an x factor down here. And these are separate, right? Because this is not being added and this one's not being added to anything. These are actual factors. So I can cancel those in this case. Really what I'm doing by canceling is I'm saying x divided by x is just 1. And then anything times 1 is just itself. So then I'm left with x squared plus 3x plus 8 times x plus 2. And then in the denominator I have 4 times 4x plus 2. And you can just leave it like that. There's really nothing further we would care to do. You could maybe multiply, distribute that 4 in, or you could go back to what we said before and factor out the 2. So these are all alternate versions for the denominator, but I really don't mind how you do that. It kind of depends on the problem you're working on, which one's easier to use. Great, so that concludes our first video. Now in this video, it was really just talking about rational expressions and sort of what we can do with those. Remember, a rational expression is any fraction basically that has x's in it, polynomials in it. In the next video, we'll actually talk about the main idea in this section 7.4, which is partial fraction decomposition.